Kia ora Year 13, here's the first part of question 2 from 2017 distributions. So this is quite a strange question, and it's the first time that we've had something like this in the level 3 stats paper. But if you remember the expectation algebra stuff that we've done in class over and over, it's actually pretty easy. What we're given here is a probability distribution for some random variable x, and we don't know anything about the context for once. So instead of me going on and on about context, I'm going to go on and on about the formula to calculate the variance of a random variable. So on the next page here, we've got an excerpt from the formula sheet, and it tells us some useful things if you have used it before. This bit says that sigma squared is the Greek letter that we use to write the variance of x. Now that's not much use on its own, but down here we've got a formula for sigma, not for sigma squared. And the one that I'm going to use now is this version here. So sigma is the square root of this stuff here. So sigma squared, or the variance of x, is equal to this. E of x squared, the expected value of x squared, minus the expected value of x squared. So what we have to do is go back and calculate this thing, and then we've been given this number, so we have to subtract it squared. So I'm going to do that really slowly now. Right, so to get E of x, remember that the thing we've done over and over, and I'm going to do it here even though we've given the number 2.2, is this idea that we're getting basically a weighted average. So E of x comes from this calculation, 0 times 0.11 plus 1 times 0.21 and so on, right? And when we do that, we get 2.2. So to calculate the variance, the extra bit we need to do is to find E of x squared minus 2.2 squared. So instead of working with this line here of x's, we're going to put a new line in up here of x squared. So we're taking this number, 0 squared. 1 squared gives me 1. 2 squared gives me 4. 3 squared gives me 9. And 4 squared gives me 16. So then I'm doing my weighted average thing, not with these numbers, but with these probabilities times the number squared. So let's write that out. E of x squared is equal to 0 times 0.11 plus 1 times 0.21 plus 4 times 0.24 plus 9 times 0.25 plus, not times, 16 times 0.19. When I add those up, I get, what do I get? 6.29. So the variance of x is equal to 6.29 minus this number squared. So that's 6.29 minus 4.84, which gives me 1.62. So that's the first part of the question, and that's an achieved question because we're just applying a formula, and it's a formula you should have done over and over in your Walker workbook or out of Sigma or just from your teacher's notes. Now the next part of the question is asking about independence. So now we've got two random variables. We've got an x and a y, and we have to say if they're independent. And that means, in a statistical sense, this. So here's the formula sheet again, and this is the bit we want down here. All right, so we can simplify this here by saying we're just looking at the variance of x plus y. Now let's go back. So we've got a couple of things. We've got the variance of x is equal to 1.62, and the variance of y is equal to 1.5376. Now we have to figure out somehow if they're independent. This is giving me the variance of the two things combined. So let's look back at the formula sheet. So if x and y are independent, then this is true. Now, in our case, we've got a really simple example. We've got one x here, invisible 1, and one y. So if they're independent, then we can say that the variance of the combined thing is just equal to the separate variances added together. So what I have to test is whether when I add the two separate numbers, I get the combined number that I've been given. So what we have to do is add up variance of x plus the variance of y. And that gives me this plus this. And that equals 3.1576. And that is not equal to 5.5696, which is the variance of x plus y. So, since the variance of x plus y is not equal to the sum of the two separate variances, x and y are not independent. Now remember, in probability concepts, we had another big test for independence that comes up over and over, and I'm just going to put this in here as a little bonus reminder for that study. So if two events are independent, then we can say this: the probability of A times the probability of B is equal to the probability of both things happening. Okay, so that's all I'm going to do in this video. I know I've gone through that really slowly, but I want to come back to the merit and excellence part of the question in a separate video. So this was actually a merit question. If you got all of this correct, you got merit. If you'd mucked up your number back up here, and then you'd gone on and used it, the wrong number, and done this independence check, then you would still have got an achieve tick. Thanks for watching.